Okay, so for the three planes that I have mentioned before in the previous video, I just mentioned briefly, or maybe I've talked a lot about the control and the data plane in the previous video. I need to talk about them again with some more details and talk about how does SDN affect these planes. The first plane, or the first brain out of three brains that are exist inside every Cisco device you will buy and work with, the first one is called the control plane. This is the biggest and the strongest one of them because it does learn information from the protocols. So it learns what does the OSPF do, needs, requires, its adjacencies, its data center information, its LSAs, what does the DHCP messages, the result, the binding information, etc. The MAC address that is being learned, so the MAC learning procedure, the ARP procedure, all of those things, etc. It will learn all of them from the routing protocols, from the MAC learning, from those other IP services protocols that I've talked about, and will organize those informations, prepare them, and will download them to the other brain, which is called the data plane. Plane, not planes, plane. I'm sorry, this S. This is an extra S, and this is as. Okay, as, and the data plane as tables. So the show MAC address table is a good table you can understand by using the English language. It's human readable. Who did perform that, who did collect those MAC information and bind each MAC address with an interface, also the ARP and etc. All of those informations the control plane did. But what you are seeing by your eyes, this table, this exact table of show MAC address table resides in the data plane, in the other guy, okay, which is also known as the forwarding plane. So what's inside the forwarding plane are those tables that you see, use, or know by using the show commands, okay. Who created those tables? The control plane. But where do they live, reside, and showed inside the data plane? What actually the data plane does, not just showing you tables, that's of course it's not about that, but also does another great and important thing, which is the data plane as an identification. It is whatever or any logical or physical component that controls the frame and packet forwarding. So the control plane did learn the OSPF LSAs and did know that currently the OSPF is advertised for network number 1 and network number 2. So logically network number 1 can reach network number 2 through me, the router, by using OSPF. All of these informations and discussions were all known in the first place by the control plane. What the control plane will do is that it will record all of those information. Okay, then I will take all of those information, describe them briefly, organize them, and download them to the data plane. Now the data plane is the muscles that are responsible for receiving packets from network number 1 and knowing that based on the instructions that I received from the control plane, this packet that I have just received from network number 1 should be forwarded to network number 2 by using the OSPF metrics and algorithms. So I will forward it. I have just received it from interface fast Ethernet of 01, okay, and I will forward it to interface fast Ethernet 02. So logical, the OSPF, metric, physical, the physical interfaces, the components do all of those resides inside the data plane. Okay, so show IP route, those tables, they reside in the data plane, forwarding plane. All of those physical interfaces, fast Ethernet interfaces, gigabit Ethernet interfaces, optic interfaces, etc., do reside in the data plane, the forwarding plane, and it's responsible for all of those. Okay, so just like I said, like tables. The final thing that we need to talk about is the management plane. The management plane, the third brain, this is a bit of like not a dedicated but some guy that works for itself. It's not responsible for all of these mess, it's responsible for the AAA. Okay, so yes, collecting the information of AAA comes from the control plane, but what does or applies the AAA profiles is the management plane. The management plane is a plane that's responsible for authenticating whomever tries to access the device, authorizing those already authenticated candidates or servers, devices, whatever, tried to get access to the device and get authenticated. It will authorize them, and it will also perform the accounting profiles and configs upon them. So for AAA that we have already started in chapter 5, who does apply or take action or apply the actions of AAA inside the router? The management plane does. Okay, this is something. The other thing is that if someone was not trying to connect to the device remotely but locally through the console port, which is a physical port that you can see by your eyes, and connect a cable to the console port, resides inside the management plane. So now you have a big router with many ports. All of the data ports are considered inside the data plane. Only the management and the console ports or the auxiliary ports reside inside the management plane, not in the data plane. So these are the three planes that actually that should have been mentioned in chapter 1. I'm sorry, I really forgot about them because they were not mentioned in the blueprints of the exam. But once I saw that I should talk about or describe the effect of the SDN upon those planes, then I know that I have to mention those planes because I haven't talked about them before. So the SDN effect upon the control and the data plane, this is what Cisco wants you to know. SDN effect upon control plane and data plane. This depends on the implementation approach. If you just remember the previous video, I have talked about the SDN, what was it called? Implementation. It was the imperative approach and the declarative approach. If it was an imperative approach for the SDN, what will happen to the control and the data plane? And I think you guessed the control plane answer because I did mention it before. First of all, it will be called actually the stateful SDN. Just a naming. Number one. Number two, the controller will be responsible for learning the information. Okay, the controller, not the control plane. You see, maybe you have just missed it and said, what's the difference? The big difference right now, the controller will be the responsible brain for learning the information and then downloading them to the data plane. The data plane is still in the device because the data plane is there, the interfaces, the logical or the physical components of forwarding. Okay, so it's the interfaces. So the data plane still resides inside the devices, the nodes. And by the word node, I mean whatever device in your network, a router, a switch, a firewall, a WLC, an access point. All of those are considered to be nodes. Okay, each one of them is a separated node. So the controller right now will take the place of the control plane and it will learn the information and categorize, organize them, and send them or download them to the data plane. If the device lost connectivity to the controller, they will be powerless. I have talked about this in the imperative approach in the previous video. Okay, if it was a declarative approach, it will be called the stateless SDN, and the controller will only declare how it wishes things to go on in the network, and then the device will react or behave from itself in the future, just in case it needed to behave or to react. So I believe it's some kind of another review this video was for what I've talked before, because I did mention the approaches in the previous video, and I have also mentioned the implementations, which I mean the approaches, and I've also mentioned a bit of the planes in the previous video. So far we have talked about the SDN, the idea of the SDN, which is this one. Okay, the SDN, first one, the SDNs and the controller of the SDN, the implementation, architecture, and its effect upon plane. Okay, so we can talk right now about the DNA center, okay, because I have already talked about DNA center in chapter 1, so I will talk again about them. It will not take a lot of time, but the Cisco DNA center, it is the appliance that I have mentioned in the first video of this chapter. Okay, it's a box that you will buy. Okay, I have a bit of disaster with the pen these days. Okay, so it's a box, it's an appliance. Okay, actually it's a UCS server. from Cisco that you will buy, and you will find an API controller built in inside it, inside this device. Cisco DNA Center actually stands for the Digital Network Architecture. From the name of it, it's a digital network architecture. It is an appliance, comes in various models, depends on the number of devices or nodes supported inside your network. It's a central management, central automation, central analysis point when you can manage, automate, and analyze the entire network, your entire network, with all its different and various types of devices and models from a single point of view, only one application. It gives what's called an intent-based networking. What is that? That is actually only the concept of controlling a network by a software. So SDA Cisco would like to recall the term SDN to intent-based networking. That's it. Okay, don't get any headache or confusion with be confused with that. Okay, it allows to design and create topology maps for your network automatically, and you can also create some, maybe design some future topologies and save it inside this appliance, and you can apply it later. It designed also some wireless LAN SSIDs, radio frequency channels that I have talked about in chapter 6. All of them can be applied for your entire network, your entire access points, through one single device, from one single device, not from multiple access points or multiple wireless controllers. It is managed through a GUI. You will not use CLI with DNA Center. You will find a GUI that controls and does everything to your devices. It has a built-in APIC controller that I have talked about. APIC logically stands for the Application Policy Infrastructure Controller. So APIC is a controller built in inside the DNA appliance, which is a controller. Okay, it also has another built-in component which is called the NDP, the Network Data Platform. If the controller does everything to your network from an action perspective, from configuring, optimizing, software upgrade, reboot, initial config, downloading config for devices remotely, all of this is done by the APIC controller. Then the NDP part does the analyzes problem, show them, and suggest some solutions. I did mention in the first video of this chapter that automation includes automated troubleshooting. So automated troubleshooting or suggestion is mentioned, or actually is done by the NDP. So this is what you need to know actually about the DNA. But previously or recently I've just know something wonderful actually, which is, let's use our web browser. Okay, and I think that because of the camera, not the entire screen will be clear to you. That should be good. So there is a link that Cisco have offered for us. Okay, and that link was developer.cisco.com. There is certification, start now, netconf, good. Okay, but it's not one of those. It's site sandbox. This link will lead me to, it will take a bit of minutes in this video to show what the DNA looks like in the real life, just in case we have, or we had an $89,000 and we purchased a DNA. You can see right now in the quarantine period, the entire republic are working from their home, so the internet is a bit of weak. There is a link called Get Started with Sandbox, but first I need to log in using my Cisco account. Just in case you have no Cisco account, you can create one for free using your personal email. No need for a partner company email if you are not working in a partner company. This is my old ID. Okay, let's try to log in, and the password, thank you. Let's see if we are logged in so far. Okay, so now I'm logged in the ASG and get started with sandbox. Now we are moved to the another link which is called the devnet sandbox.cisco.com. Yeah, actually this is the internet right now in Iraq. You can imagine that. A big disaster. You can only imagine how many hours will I need to upload those videos of the chapter 7 to YouTube, since they are all of them are recorded with full HD. I believe that if you have just done the same steps that I'm doing so far, then you have already become or gained access to the DNA center. So let's just wait. We can do nothing but waiting. I will no longer need this tab. Mhm. There is a bit of problem with the Cisco site. Please refresh. Please refresh to try again. I will refresh. No worries. Okay, loading. Hey sandbox users, the sandbox will be undergoing system maintenance and between April 3rd and April 6th. I will do my best to finish recording both languages before that. Now there are some Cisco devices that are available and you can reserve, okay, freely from for a short period of time that you will decide, and Cisco will prepare this device for you and will allow you to access it remotely, so you can maybe perform a lab, or you can see, look here, there is a Cisco Catalyst 9800 wireless controller. It's always on, doesn't need a reservation, so I can just click right now and I will get access to the device. Okay, but what we need is actually a Cisco DNA server, DNA center. It's always on lab and it's always on, doesn't require a reserve. So click on the always on and let's see if we can access the DNA center. Actually, just a side note, currently, if you have seen so far in this chapter, I have always used the pack tracer for hands-on labs. Juniper Networks, which are the company that I've talked about, those guys with the green certificates, which are just like Cisco, another American company that produce the same devices, routers, switches, firewalls, multi-layer switches, etc., everything, the same technologies, etc. They unfortunately do not have the emulator, so they produce other methods for accessing their devices, which are called the VLabs, the virtual labs. And the virtual labs looks just like this, a sandbox with some blueprints, etc. Because when I did access for the first time for this DNA for the Cisco sandbox, I was shocked that okay, Cisco also use the sandbox. I thought only this the Juniper Networks use it. So this lab requires no reservation. This lab here, okay, I got it. What do we have in here? There is a DNA center. It's connected through the public internet to a router which is have the model of ASR, aggregated services router 1001X. This is a very expensive and very beautiful device that is connected. You can see the coincidence that these were my two favorite devices before. I have worked a lot with these two. That is connected to a layer 2 switch, which is the Catalyst 3850 device. I believe this model that comes with like 12 10 gigabit Ethernet port, or maybe multiple fast gigabit Ethernet ports, not just 10 gigabit Ethernet ports. This switch is connected for two other switches from the Catalyst 930 series and are connected to a hosts. Okay, so this is just a topology. These are some instructions and notes, and we have to access to the sandbox. The first thing I need to access the sandbox dnac.cisco.com, accept the certificate, allow for showing browser notification, and use the credentials of devnet user cisco 123 and an apostrophe mark. I believe it's called an apostrophe mark. So devnet user. So number one, let's go to this link. Actually, it should also be accessible from here. Yes, because there are no, it's not from here. So login data center. Okay, hopefully it will work. Sorry. Okay, so the username was devnet. Devnet what? Devnet user, and the password that I have copied. Login. No need. Success. Thank you. Okay, so this is how a DNA center looks like from the inside. This is everything. Okay, so this is the network devices, healthy devices. All of them are healthy for the last 24 hours. The wireless client, currently there are no wireless clients. The wired clients, all of them are healthy. View overall health for more information. Network snapshots, sites. How many sites or regions do I have inside my network? How many network devices? 4 network devices. Unprovisioned, 4 of them. Unreachable, none. Unclaimed, none. Good. Application policies, no policies. Licensed devices, only 2 switches of them are licensed. Okay, which are, I believe, let's see how many devices are there already. There are some images and no profiles, so you can see that everything is in here. I can design a network. I can use policies to automate and simplify the network management. I can use provisioning with is a new service to users with ease, speed, and security across your enterprise network, regardless of the network size and complexity. By discover devices, manage unclaimed devices, good setup fabric across sites, and assurance tools. Tons of tools. Actually, there are 9 tools: license manager, telemetry, command runner, discovery, inventory, topology. So brilliant. This is everything. This is what controls your entire network with all its different types of devices. This is how a DNA center looks like from the inside. So Cisco are making this for you to see and to know how useful it is. Okay, so I have right now access to the discovery. User under observer role has been granted limited permission, of course. Okay, so these are some extra informations. Actually, I've asked only for the devices, for my devices. Okay, anyway, you can navigate it yourself. You can discover a lot of things. I don't know how much privileges are allowed or authorized for you as a DevNet user, but you can try it yourself. Okay, you can see everything is for free. You can create a free Cisco account, access free in here. No reservation is needed. You can just directly get access to the DNA center, and that's it. That's all you need to know about the DNA center in this certificate, and I hope everything was clear to you. Okay, after the SDN and DNA have been done, we'll move to a new things or a new subject that we will talk about in the upcoming video. So thanks a lot for watching, and I hope to see you in the upcoming video. Goodbye.